Moving on to question 3, I will immediately look for the goal, and that is to explain why the battery is connected as shown in the diagram. Alright, well, let's take a look at the battery, and I need to remember there's more on this side, so that's going to be the plus. If you have a hard time remembering which side is plus and minus, and that means all these, this top plate here will all be plus, and the bottom plate will be negative. Now, why would we want to have a setup like this? Well, I suppose we're going to have to take a look at the information here, and it looks like Millikan was determining the size of a charge on an electron. He put a charge on a tiny drop of oil. It's not exactly clear, but it's going to be a negative charge on this drop. So we're sort of expected to pick up on that. It's not too clear, but it's one thing that you must pick up on, that the oil drop has a negative charge. So why would the battery be connected like this? Well, let's answer the question. The top plate will be positive, which will attract the oil droplet with a negative charge and help prevent the oil droplet from falling. This attractive force will balance the force of gravity acting on the oil droplet if and when the system is at equilibrium. So the charge on the droplet can be measured very accurately, which is why the battery is connected the way it is. Just quickly go back over my work and make sure that we put some directions into our vectors. Force is a vector, so good idea to put in some directions for them, just in case someone's going to be a stickler when they're marking you. There we go. That's better. Now, moving onwards, let's take a look at the next question. In terms of forces, state the conditions necessary for the oil drop to be held stationary between the horizontal plates. Well, we pretty much already answered that, so we're going to need the downwards force of gravity on the droplet must equal the upwards force of attraction via the electromagnetic field of the positive charged plate. The total forces acting on the droplet must have a net sum of 0 for the droplet to be in equilibrium. Definitely want to include the proper terminology that you understand. Equilibrium. Moving on to the next question. Let's give ourselves a goal to work towards. Calculate the voltage needed to hold the oil drop stationary between the two plates. Tells us how to start. Work out the weight force of the oil drop using this equation they give us and all the information we need. That's great. I'm going to quickly make a note here that the main question is to find voltage. So I'm going to track my data. I have a mass given, which is 2.54 times 10 to the negative 5. And that's coming from right here. I've got a charge given as 3.6 times 10 to the power negative 9. And there's a distance given of 4.8 times 10 to the negative 4. Alright. Now, it's definitely not a waste of time to have tracked this data, because now I don't need to pull it out of the paragraphs. I can utilize it here right where I need it. So, using force of gravity equals mass times acceleration due to gravity, I'm going to use the mass here, and gravity 9.8. Electrostatic. Maybe we can go ahead and have a gander at the formula sheet, see what we can find out about any electrostatic forces. So I do recognize this formula right here is looking pretty good, and that's where we can carry on. So I know that my force of gravity is 2.4892 times 10 to the negative 4. And that's going to equal that force electrostatic, which is also equal to EQ. Alright, well, if we're sort of losing track of what's happening, we definitely want to find voltage And ultimately in this situation, voltage equals ED. There's your electrostatic field strength. That's the distance. So, I mean, if you're ever sort of stuck, you can do what I just did. I sort of went back and looked, right? That's what I want to find. What does that equal in this situation? Well, voltage equals ED in that situation. So I can sort of clearly see, right, this is really what I want to calculate, because I know what the force is. I got that from calculating the force of gravity. I know what the charge on the droplet is because I've tracked that. That's that right there. So let's rearrange this equation so we can get something useful out of it. E will equal the force gravity divided by the charge on the particle. So that's 2.4982 times 10 to the power -4 divided by the charge, which is 3.6 times 10 to the power -9. Hopefully everything goes right with your calculator, and that equals to 69,144 newtons per coulomb. So now we do have the electrostatic field strength here for this equation, which is going to calculate the target question. So now we're looking at simply applying this equation plugging in our data. So if voltage equals ED, E we found was 69,144. We're going to multiply that by the distance. Some new information coming in, but we tracked it, so we're good. So 69144 times 4.8 times 10 to the power of -4, and we should get a voltage of 33 volts from that calculation. Let's work this to some significant figures and give a reason why we're going to choose that number of significant figures. So we're going to say answer is in 2 sig figs, and the reason is that data given is in 2 sig figs. So sorry, the answer is in 2 significant figures because the data given right here in particular and right here, those are only 2 significant figures. So we cannot answer more accurately than the data given. All right, that's worth merit right there. And that leaves us to take a look at question number 4. Hey, thanks for watching. If you have some time, why don't you click on this link in the description box of the video. That'll take you to Paid Surveys at Home, which is an awesome database of websites that pay you to fill out surveys. I've checked this out myself. The database is totally legit. This site itself provides the database and also the know-how for maximizing your profits and maximizing your time to profit the most with the system of staying at home, working whenever you like, and basically filling out surveys to make some extra cash. So if you want to make some extra money at home, check out this link at the bottom of the video in the description box.